Hello and welcome. The following AFL presentation will cover optical fiber cleaning and inspection, methods and tools for both outside plant and inside plant applications commonly found within data center environments. Several topics will be covered, including industry drivers and requirements, cleaning and inspection fundamentals and methods, as well as applications and solutions. Let's start with industry drivers and requirements. There are many elements that make up a high fiber count ecosystem commonly found within data center applications. These include everything from the backbone cabling to connectivity components such as splice cases and patch panels, all the way to the test and splice equipment used to complete and verify the fiber optic link. A main driver for more sophisticated fiber optic testing and inspection is the reduced loss budgets specified in higher bit rate systems, such as 40 gig Ethernet and above. Loss budgets have been reduced dramatically for 40 gig and higher when compared to more traditional 10 gig systems, in some cases by 1 to 1.5 dB, or even higher in the cases of emerging low power single mode systems. In a typical leaf and spine, loss budgets have dramatically decreased as low as 1.9 dB over multimode fiber. Even with ultra-low loss components, this can have a significant impact on the overall system, thereby making low loss components critical to the overall system. High-speed applications with low loss budgets require loss testing always, and inspection and cleaning become critical. Now let's review inspection and cleaning fundamentals and methods for fiber optic connectors. There are several questions when it comes to cleaning and inspection. Why is cleaning and inspection even required? If I purchase a pre-terminated solution, isn't that clean right out of the bag? What is clean? There have been many studies performed to determine the issues contributing to physical network failure. Time and again, dirty or damaged optical fiber connectors and end faces have been found to be the primary culprit. In some cases, over 90% of network issues could be attributed to end face contamination. Another driver for the need for increased end face inspection is the changing workforce within the market. In order to minimize costs, installation and turn-up of fiber optic networks are increasingly being outsourced to contractors, some of which may not have had extensive fiber optic experience. As an end user, it is generally prudent to require verification of network performance and component quality through test reports and documentation. It is also important to realize that just because an application may be in a clean room or a controlled environment, contamination may still be present. Common Class 7 and Class 8 environments still allow for thousands of 5-micron particles per cubic meter of air. So what really happens to an end face if it becomes contaminated? Dust, dirt, and oils can literally block the light and cause additional loss in reflectance. And in extreme cases, contamination can cause physical damage and even improper mating. A typical single mode fiber has a core diameter of 8 to 9 microns. The average human hair has a diameter of 150 microns. While a human hair is likely visible to the technician, smaller particles generally are not. Dust, lint, and pollen are too small to be seen with the naked eye, but are still larger than the core of a single mode fiber and could potentially block the light signal. In addition, a fiber optic link is only as clean as its dirtiest connection. It is important to clean all end faces that are physically mating with each other to ensure a clean path throughout. One dirty connector can contaminate several others that it may come into contact with, including those present within test equipment. Finally, there is a real effect on transmission performance. end face contamination can be the cause of several dB of additional loss and reflectance, resulting in potentially poor network performance and degradation over time. Here you see a difference in the loss value between a dirty and clean fiber of over 0.6 dB. So what exactly is clean? IEC standard 61300-3-35 specifies requirements for contamination within each zone of the end face. Zone A is the core of the fiber, where the primary signal is transmitted. Contamination requirements are the most stringent in Zone A. Moving away from the core to the cladding to the coating, all the way out to Zone D, the requirements relax. Whether or not an end face passes or fails is determined by the amount of contamination measured within each of these zones by the inspection probe. With regards to factory terminated cables, it is often assumed that these cables do not need to be cleaned upon opening of the packaging. However, even factory terminated cables and components can be susceptible to contamination from a variety of sources, including transportation and warehousing. Therefore, it is always recommended that even these factory terminated cables be inspected and, if needed, cleaned prior to connection. For best practices, follow the IC method. Inspect, clean, inspect again, and connect. This will assure contaminated end faces are not connected inadvertently. So to review, IC, inspect, as in inspect all connector end faces. Clean, as in clean all end faces that are contaminated. If clean, there is no need to clean again. Inspect again, as in inspect again to ensure cleaning was effective, and if it's still not clean, re-clean. And finally, connect, as in once everything is inspected and determined to be uncontaminated, it is now safe to connect. And finally, let's review some typical outside plant and inside plant applications and solutions. Applications between data centers and halls include outside plant backbone cabling, as well as connectivity that may either be installed in an outside enclosure or internal cabinet or rack. These cables may be terminated or spliced to single fiber connectors, such as LCs, or multi-fiber connectors, such as MPOs. There are hardened or ruggedized versions of some of these connector types as well. Here is one example of inspecting and cleaning an outside plant connector. In this case, the digital inspection probe needs to access a ruggedized connector both within a drop terminal and as part of a drop cable as well. Standard probes can be used. However, a connector adapter tip optimized for use with hardened OSP terminals is required. Some probes are able to inspect both cables and terminals without the need to swap between different adapter tips. There are several manufacturers of hardened terminals and cables. Depending on the manufacturer, different adapter tips may be required. Ultimately, adapter tips optimized for hardened components will provide the best results. Applications within a data center may include components such as backbone and distribution cabling, rack-mounted patch panels, and splice trays, as well as patch cords. These cables may be terminated or spliced to single fiber connectors such as LCs or multi-fiber connectors such as MPOs. There are several types of digital inspection probes suitable for these applications. These include probes optimized for single fiber inspection of cords and bulkheads such as LC, as well as those optimized for inspection of multi-fiber cords and bulkheads such as MPO. Some of the benefits of using a digital inspection probe include safety. The technician is not looking directly into a fiber that may be transmitting a live signal. The probe will shield the technician from this potentially hazardous situation. Quality. The digital inspection probe can see contamination that the human eye cannot, therefore providing a higher level of quality in the results that are reported. And ease of use. Previous inspection probe technology relied on a user having to hold a connector stable in one hand while holding the probe in the other, and simultaneously holding the device to their eye, and then subjectively determine if the end face looked acceptable. Today's probes can be used with one hand and even paired with a smart device for easy viewing. As physical network requirements become more stringent, with the installation of higher speed network systems, documentation and proof of quality and acceptance has become common. It is important to utilize tools that are able to save, share, and report end face results and images. There are many types of cleaning tools available, including dry push-type cleaners such as the one-click, reel-type cleaners, and even wet cleaning pens and solvents. Often these tools are combined into a cleaning kit, as the technician often may not be aware of what will be required in terms of connector type or what type of cleaner will be effective for the application. A push-type cleaner, commonly known as a one-click, is among the most widely used cleaning tool today. There are many models depending on what is needed for connector type, LC versus SC versus MPO, as well as for connector access, such as the mini type for applications within tight spaces. They are all cost-effective, easy to use, and readily available. It is important to utilize a one-click with the proper technique. Improper mating or insertion of the cleaner will result in an incomplete job and could potentially damage the cleaning tool. To properly clean a fiber end face through a bulkhead adapter, first remove the guide cap from the one-click cleaner. Insert the cleaner straight into the bulkhead adapter and push. A click sound indicates the fiber end face has been cleaned. Remove the cleaner from the bulkhead adapter and put the guide cap back on. To properly clean a fiber patch cord end face, flip open the guide cap cover. Insert the connector ferrule into the guide cap of the cleaner. Push both the connector and the cleaner together. A click sound indicates the fiber end face has been cleaned. Remove the connector from the cleaner and close the guide cap cover after use. Follow these same steps for all one-click varieties, including LC, SC, and MPO 12, 16, and 24 fiber. Generally, dry cleaning, such as with a one-click push cleaner, will be sufficient for the large majority of connector contamination. However, contamination from oils or grease are a bit more stubborn and may require a stronger degree of cleaning. For these cases, a cleaning solvent is used. Alcohol less than 98%, while it may be effective in some cases, is not recommended as it may leave a residue that could contribute to contamination. Because of this, a final dry clean with a one-click is always recommended after the use of any solvents. And as connector types proliferate, it is important to recognize and understand what tools and components are required and available. There are many types of adapter tips and cleaners specifically produced to accommodate the varying connector types available. Tools with the flexibility to accommodate many different types of connector form factors will prove to be the most efficient and versatile. Thank you for listening. Please visit our website at aflglobal.com for more information on inspection and cleaning tools, as well as all types of fiber optic testing and splicing equipment.